Hello and welcome to this StormCrawler tutorial. This covers the version 1.16 of StormCrawler and Elasticsearch 7.5.0. So as a starting point, we will assume that you have installed Storm on your machine, running as a service with the UI available, the supervisor, and Nimbus. There is a repository available with Ansible scripts to help you deploy Storm running as a service. So have a look at that and install that first. Also, you need to have Elasticsearch up and running as well as Cabana on this machine. And in the rest of the tutorial, I will guide you through installing a set of resources for StormCrawler that will use Elasticsearch as a backend. So here there's you can see a server on EC2 I had up and running with Storm. So this is the Storm UI, and it also has Elasticsearch and Cabana. To install Elasticsearch, have a look at the instructions on the Elastic website. I followed the steps for Debian distribution, and if you do the same, should be fine. Likewise, I installed Cabana in the same way, and I will show you, the resources provided with StormCrawler to get up and running. So your Cabana should look something like this. So first, if you look at the StormCrawler repository on GitHub, you will find a number of things under the Elasticsearch module. But first, the command we're going to run is a Maven command to generate an archetype, and that archetype will be used for to get all the stuff we need to run StormCrawler with Elasticsearch. It's new in StormCrawler 1.16, and you call it like so. So you take the copy that command. So you open a terminal on the, for instance, on the server where you have Storm and Elasticsearch running, and that will get us all the stuff we need. So going here onto the terminal on the server. I had created a separate user to run the all the StormCrawler stuff. Going into the home of that user, and then calling the Maven archetype command. All the dependencies are downloaded, and then we need to enter a group ID. It could be anything you want. Here I use Digital Pebble, Artifact ID, again anything you want, and version you can leave at 1.0. That's the packaging for the Java classes generated, and a summary of the things we entered. Done. So this created a set of resources in the crawler directory. So if we have a look at that, you can see a number of things. An init script to initialize the schemas for Elasticsearch. But if you look at the README, you will find all the information you need to get started. So if you can't go wrong by following the steps in the README. First one, Maven clean package. So what this does is that this compiles the Java classes and packages all the dependencies into a big fat jar, which we will use for running on Storm. Also, this includes all the resources and configuration files that are needed. So you see a number of things. So we saw the README, then there's two YAML files for the configuration of StormCrawler in general and the ES Elasticsearch module for StormCrawler, and then a Flux file which defines the our topology, so the different components running on Storm and how they are related to each other. There's also a pump file, like any good Maven project, and a directory containing Cabana script. We'll have a look at that in a minute. So first we run the initialization script for Elastic, and that creates the templates for the various indices we need. There are several indices, one for storing metrics, one for storing the content of the pages that we crawl, and one for storing the status of the URLs. That is a set of that is the configuration of the crawler. So you are really advised to change the user agent values so that it gives people a way of identifying you and identifying your crawler. It's part of being polite. So I'm about to do that right now. All the other configuration elements, if you look at the wiki, they are described, but this is a solid set of default values. But the one you really must change first thing is the user agent. So enter the URL of the company you work for and your email, so that webmasters can find you and shout at you if they're not pleased. Done. I put my email address and everything. Excellent. Now, if we look at the esconf YAML file, this is, as I said, the configuration for the Elasticsearch part of the topology, and that tells us first where Elasticsearch runs. So here it's on localhost under the addresses, and the different indices can live on different machines. You can also specify custom names for the indices, and the rest are configurations for the spouts for the way we query the index for URLs to crawl. Next, we will have a look at the Java classes generated automatically. So you have two ways of building a topology. One is through a Java class, like so, and that tells you, that tells Storm where the various components are and how they are connected. So that's one way of doing, and that class is a default class, and you can run the topology that way. There is another way of running a topology, and that's by using a Flux file. So unlike the Java class where you need to recompile it if you make any change to it, the Flux class, the text-based sort of declaration of the topology can be edited, and you don't need to recompile. You can just restart Storm with the modified version. So here it says, it tells Storm to use 10 spouts for reading the URLs from Elastic, from the status index. They are grouped per key, usually the host name of the domain, so that we don't get massively URLs from just one domain, so that we balance URLs to fetch across domains. And also here it reads from a file containing a number of seeds, and seeds are just your starting point for the URLs that you'll use as starting point. here are the other components of the topology. So the bit that actually fetches the URLs, the parsers that will extract, either the sitemaps or the HTML, extract the text and metadata from the HTML, an indexer which sends the extracted text and metadata to Elasticsearch to build a search engine, and various other bits. Of course, you don't have to use Elasticsearch. You could use another backend for storing or indexing, for storing the status of the URLs or the indexing. And that's, I think, one of the great strengths of StormCrawler, is that it's very modular, and you can just plug new things while keeping the core components unmodified. First, we need a set of seeds. So here I copy, I think, a list of 1 million top domain from OpenDNS from a few years ago. That could be used as a starting point for a generic crawl. I rename that file into seeds.txt. There are indeed 1 million URLs in there. If we look at the PUM file, we can see a list of dependencies used by our topology. One of them, of course, is StormCrawler itself, the core module of StormCrawler, but also the Elasticsearch module, as well as Storm and Flux. Going back to the README, now that we have covered all the bits generated by the archetype, we're probably ready to launch the crawl topology. So in Storm, you can run things in either local mode or remote mode. Local means it doesn't run on the Storm services, and it's not distributed. It just runs in a local JVM. Remote can be, of course, in a fully distributed Storm cluster, or just on the same machine as you happen to be on. But the advantage of running in remote mode is that you get you benefit from the Storm UI, the proper logging, and parallelism. Local is useful for debugging mostly. So here we launch the topology using Flux in remote mode. A few messages, and yeah, it's been submitted successfully to Storm. So if you look at the Storm UI, you can see need a refresh, and then you can see the crawler topology and the different components, the different bolts it contains. As you can see, the file spout has so reads from the file, sends them to the URLs to the status update bolt, which writes them to Elasticsearch, makes them persistent, and then we have a normal Elasticsearch aggregation spout with 10 instances, which will read from each Elasticsearch shard and send URLs to be fetched and so on. So the file spout is just used just as a starting point for the seeds, and then the normal spout takes over and sends the URLs for fetching. So the Storm UI is a great way of getting a good overview of how your crawler is behaving and the time taken by the different components. It's a very useful tool. There is, of course, Cabana. Also, we have ways with Cabana of monitoring the crawl, and this in two different ways. So if you go back to the README file, you will find explanations and steps to follow to import resources for Cabana, and it's ridiculously straightforward. You go into the Cabana directory, and then you run with, of course, you need to have Cabana up and running. And you run the import Cabana script. That sort of exports into Cabana number of 2 dashboards and a number of visualization. So if we go into Cabana, we should be able to see everything really. First, this is the status, a view of the status index. Let's go back to if we go into the index patterns, we can see that 2 patterns have been created, one for the status index, another one for the metrics. And that's something which is really nice in StormCrawler and Elastic, is that we can build sort of bespoke dashboards for and get a good idea of how the crawl is behaving. If we look at the status here, there's a dashboard which is very straightforward. It just gives us a breakdown in real time of the status of the different URLs in the status index. So discovered means we know about these URLs, we haven't processed them yet. Fetch means obviously fetched. Fetch error is that something happened. Redirection. And error is for something which is not temporary. So fetch error could be like a network problem and you try later and it works. Error is more, could be something to do, say, with the robots.txt preventing a URL from being fetched. I mean, that's not recoverable. Or less likely, I'd say, a passing error on the content, but that doesn't happen very often. On the right hand side, you can see a breakdown per key, and the key could be either set by host name by default, or the domain, or the IP address. And that's how we route the URLs into the different shards of Elastic. We also store the metrics in Elasticsearch, and again, that's real-time live stuff. You can see and get a good picture of how the crawler is behaving by seeing various metrics implemented within the bolts and spouts. You can see how many threads are actively fetching, the number of internal queues in the fetcher. So that's a very, very basic dashboard, but it can easily be extended. There's a wealth of metrics available in StormCrawler, as well as the standard Storm metrics. And if you write your own components for StormCrawler, then having your own bespoke metrics is very, very easy. The metrics mechanism in Storm is very elegant, very pluggable, and really nice. So going back to the Storm UI, we can see that a number of quite a few URLs have been fetched already and acknowledged, and we can see the performance of the different components. So if we kill the topology using the UI, we do that like so. And going back to the root of the crawler code, back to our starting point. I will change something here in the configuration. I use 2 workers instead of just one. So worker is like a JVM, so it could be in the same Storm in a machine or two different ones. And I'll change the number of threads used by each fetcher bolt to have a bit more threads used for fetching stuff. The default values are quite conservative, really. What else would I change? Because we changed the number of workers to 2 workers, well, we can increase the parallelism of all the components to 2, which means that each worker, each JVM will have 1 copy of a component, except for the parser bolt. So rule of thumb, you can have 4 parser bolts per fetcher bolt. Again, depends on number of threads used in the fetcher bolt, but the fetcher will use basically mostly network and the parser CPU, so that balances things a little bit. And then all the other components are set to 2. So we'll increase the parallelism a little bit, and hopefully increase the number of URLs being fetched. So now we go back, we don't need to recompile because we've just changed the text files, and we start the storm command again, same as we did earlier. We go back to the Storm UI. You can see that the crawler topology has been recreated. We can see 2 workers now, not just 1. Even though it's on the same server, on the same machine, it means we have 2 JVMs running. Of course, on a proper cluster with several machines, the workers would possibly be on different machines. And all the parallelism of the different components has been updated. You can see also the if you click on the port number here on executors, it will take you to the logs for those workers. It's a good way of debugging your topology. So yes, we can see it's already done quite a few URLs. If we update, you can see that you have 2 different colors because we have 2 fetchers. So each instance of a bolt is a different color, and we can see that it's going a lot further up than the previous set. The previous run we had capped on 50, and now we've put 100, I think. So we have each instance will use up to 100 threads. So it should be something like, it's actually, although the bars look very similar to the first run, it's actually almost twice as much because we have 2 instances, and also each does twice as much. It's 4 times as many URLs fetched per minute, roughly. You can sort the components per capacity. So capacity gives you an idea roughly of how much of a bottleneck each bolt can be. The fetcher is a bit of a special case. It doesn't really reflect this because it's all done asynchronously. So you have to bear that in mind when looking at those figures. So I really like Cabana. Yeah, it gives us a good way of exploring the content of the status index in real time, something you can't do with, or very hardly, difficultly, with something like Notch. And that's the beauty of StormCrawler, is that you can get the metrics and also explore the content live. So I love Cabana, but I also love Grafana. So here, you go on the Grafana website, you can see the commands for installing Grafana. I think we're about to do just that on the server. And then I'll show you how to import the resources to display the metrics in Grafana. If you go on the Grafana website, you'll see all the steps needed. So, following the steps, we start the Grafana services. And if you go on port, let's click on this one. If you go on port 3000, so we enter the default password for Grafana, which is admin, I think. Can change and add a new one. First step is to add a data source. So we'll tell Grafana to get the metrics from Elasticsearch. So we click on Elasticsearch as data source. Here it runs on the same machine as Elastic, so it's just localhost 9200. Then we give it the index name. So here it's metrics. The field is called timestamp, but without the arrobas. And the version of Elastic is 7+. Save and test, all good. It could read from Elastic. And now we want to import a dashboard. So if you go into Grafana, and it's not available here, but if you go on grafana.com, you should be able to, or here, you can find the dashboard for StormCrawler. This is 2363 is the ID of the dashboard. So let's go into Manage Dashboards. 2363. Then we need to tell it where to get which Elasticsearch to connect it to. So we select the one we defined earlier, import. And that loads a default dashboard for StormCrawler in Grafana that reads from the metrics from Elasticsearch. It reads the same metrics as we were using from Cabana, but just displays them a little bit differently. We can see the white bars here tell us when a new worker was created, basically when we restarted the topology. And here we get a breakdown of the number of pages per minute, number of robots TXTs found, and number of exceptions. Here, the list of 1 million seeds we used was very messy, and the reason we get so many exceptions is that a lot of those websites have actually disappeared since. We get the breakdown per status code. So the this dashboard has probably changed since, or will change by the time you look at this tutorial. But the core elements should still be there. And we can, similar to what we had in Cabana, we can see the information about the number of queues, number of threads, the bytes per second and bytes fetched. Also information about the spouts, average query times of the spout instances, and various statistics about the spouts. Also the growth of the status index in size, just below in red. Here we can see, going back to the spouts, how many URLs have been obtained from Elastics and sent down the topology. So it's and here, the breakdown per status of the our status index, and at the very bottom, the number of pages indexed into Elastic. So you can also restrict the view per worker or host, and dice things that way to get a view on a larger cluster of how what happens. So it's a really good way of monitoring your crawl and make sure that there's nothing dodgy with the crawl. And it's a good complement to the Storm UI. You can see a number of failures here. They're not necessarily nothing sinister. It could be that Storm has a timeout mechanism for a tuple to be executed, and sometimes you get a failure. It's just a URL could not be processed within that timeout, and it's just we try it later. It could be that there were far too many URLs for that from that domain to be fetched. So here we've gone back to Cabana, and we're looking at the status index a little bit. So again, a great way in real time to look at the content of the index and explore things and see what's been fetched and the errors and what's been successful and so on. Again, something for those of you who have used Nudge, it's not quite like that in Nudge. You need to run jobs, they take hours or days, and it's not that interactive, really. Here we just have a quick look at the metrics. So the ones we displayed so nicely with Cabana and Grafana, under the bonnet, they are just documents indexed in an Elasticsearch index. So here I mentioned two of the indices, the metrics, the status, and the other one is the content. So in the scenario we are playing here, in a way we're building a search engine. So all the documents that are being crawled, the text is extracted. We extract metadata like the keyword field in HTML, or the domain, the content type, the title if there is one, and so you can see here the content of the content index, so to speak, and we can just for fun just run a query saying, hey, I want document with a crawl in the title. There's no such thing. Or crawl in the text. Nope, no luck. And we've done something a bit wrong here. Cabana is not happy. looking at all the documents. You can have a quick look. And you can see, for instance, yeah, in the title, so using something less nerdy than crawl, like refinance, we see the documents found through by the crawler that match this. So if you were to build your own Google or your own search engine, of course you would build a UI on top of that, but the content index populated by the crawler would be the data you would query against. That's it for today. Thank you very much for following this tutorial. And if you have any questions, as usual, go to Stack Overflow or get in touch on GitHub. Bye.